Yuk.
Assalamualaikum warahmatullahi wabarakatuh. We are from the group 2 and we would like to present our observation about installing point-to-point fiber optic in Bogor with me, Shania Wardani, and my friend Dewa Raviandra and Robby Putra Sigit. Next, introduction. In the dynamic landscape of modern communication system, the seamless transmission of information is achieved through integration of diverse technologies. The integration optimizes perform and address a specific requirement across various communication, distance, and application. A notable example of this approach involves the fusion of electromagnetic as amplified by radio frequency communication and fiber optics. And next is map routing. We can see the fiber optic route from Telkom STOC Jeruk to Telkom STOC Apus will pass through 6 different roads, and the total length of the route is 6.9 kilometers. And then next is installation type. Considering the route from STOC Jeruk to Ciapus, which refers through numerous residential homes, shops, and areas with busy yet smooth traffic, it has been observed that the presence of numerous electricity poles make a real installation a suitable choice for this location. And then fiber optic cable. Silk fiber optic cables are the best protection for overhead cables. They are built to withstand pressure, high pressure, and rodent problems. These cables are much stronger and more durable than ordinary, ensuring smooth data transmission in various conditions. The route design not only protects against physical threats, but it also increase the overall reliability and lifespan of fiber optic network. This make it a top choice for a critical application where maintaining cable integrity is critical.
Okay, so now I'm gonna discuss about fiber optic specification. The first one about the fiber optic specification has uh to like ITUT G652D, a single mode. The single mode fiber or SMF appears to be the optimal choice for a 6.9 kilometer distance. SMFS, characterized by their smaller core size, are well suited for transmitting signal over extended distance due to their lower attenuation. The second one is photodiode IPD. An avalanche photodiode or APD is a highly sensitive semiconductor photodiode detector that exploits the photoelectric effect to convert light into electricity. Okay, so this is a bill of quantity. They have a component and the price, right? The first one is a fiber optic cable. They have a 4 spools, and the price is 12 million rupiah. The second one is a connector. They need the 5 connector, and the price is 3 million. And the third one is a splicer, and the price is a 40 million rupiah. And the fourth one is a claver. The price is to 200, right? To 200 to 200,000 rupiah. And the last one is like source. The price is a 900,000 rupiah. And then the total for the price is a 59 million 100,000 rupiah. So this is a fiber optic characteristic. So the first one is a cable line. They have a 6.9 kilometers or 4 spool needed. And the second one is mode. They use a single mode. Okay, the third one is a wavelength. They have 1515 Newton meter, and the fourth one is a maximum attenuation. They have 0.25 dB per kilometer. And then the dispersion material, they got 18 PS per Newton meter kilometer. And the next one is a Haspel. They have 2 kilometers set zero, and the fiber loss is 0.3 dB per kilometer set zero. And then the splicer loss is 0.05 dB set zero. And then connector loss is 0.3 dB set zero. Okay, so this is a transmitter or TX. For the transmitter, they have average launch power. They got 2 dBm. Second one is a output spectrum width. They have 1 Newton meter. And third one is a rise time transmitter. They have a 35 PS. And the fourth one is spectral width. They got 0.1 Newton meter. And the fifth one is a bit rate. They have a 1.2 coils by 10
Right.
ya derajat 8
And
BBS.
with the format modulations of NRZ and RZ. Okay,
Okay.
next. And here is the receiver. So it has a sensitivity of minus 34 dBm and the rise time of 500 PS. Okay, skip. Next. So here is the link power budget, and it is the total limit of power required to send a signal from a signal source to a signal receiver through the transmission network. And this includes all devices used in a network, including transmitter cables, active device, as well as receivers. And here, we calculate the power link budget for all sets of link designs with multiple alternative bit rates. And the power link budget remains constant across all sets, with variations in bit rates not influencing this parameter. Next. So the next one is the rise time budget, and it is the time limit required for a signal to increase from a low level to a high level in transmission network. And it is measured from the time the signal begins to increase to the time the signal reaches a certain defined level. For example, it's 90% of the maximum amplitude. And the rise time budget is used to ensure that the signal is received properly and to minimize interference with other signal that may be received by the receiver. And this formula is important as it will be used for NRZ and RZ mode analysis about transition time degradation. Next. And the next one is the bit time. And bit time is the durations of time taken for one bit to be transmitted in a digital communication system. And it is the reciprocal of the bit rate or the number of bits transmitted per unit time. And the formula is TB equals to 1 divided by RB. Next. So as I mentioned earlier about multiple bit rates, in anticipations of potential increase in data traffic and to facilitate a comparisons of the most viable sets of link designs, various alternative fiber optics characteristics have been considered. And here are the following sets. The first one is set 0, which has 120 megabit per second, as been mentioned in previous slides. The set 1 is 500 megabit per second, the set 2 is 1 gigabit per second, and set 3 is 10 gigabit per second. Okay, next. So here is the line coding when we perform the NRZ and RZ mode analysis, in which we will determine if the link signal is fulfill the requirements. So it could perform either NRZ or RZ mode. The formula is a rise time budget must be less than TB multiplied by RZ. Now, TB multiplied by RZ is 35% multiplied by TB, while for non-return to zero mode, it's TB multiplied by NRZ, which is 70% times TB. And the rise time budget must be less than that. Okay, next. So after we perform the RZ and NRZ mode analysis, we know which sets that fulfill the requirements for NRZ and RZ. And here we can see that the set 0 and set 1, which has 120 megabit per second and 500 megabit per second of bitrate, fulfill the NRZ and RZ modes, while set 2 only fulfill the NRZ, and set 3, which has 10 gigabit per second, did not fulfill NRZ or RZ at all. Next. So the conclusion is that the link designed for the point-to-point connections between Telkom City STO Cijeruk and Telkom STO Ciapus covers a distance of 6.9 kilometers, featuring a data rate of 120 megabit per second in set 0. And the link of power budget assessed at 1.42 minus 1.42 dBm, which applies for all sets, and it is greater than the sensitivity threshold of minus 34 dBm. And this ensures compliance with the link power budget requirement. And in optical communication power, the link power budget is a measure of the available optical power margin. And it indicates how much the signal strength can degrade along the optical link while still maintaining a reliable communication link. The sensitivity thresholds, on the other hand, represent the minimum signal strength that the receiver can detect and correctly interpret. When the link power budget is greater than the sensitivity thresholds, it means that the received signal has sufficient power margin to withstand losses or attenuations along the optical path. Next. The last is furthermore, in anticipation of potential surge in data traffic and to enable a comparison of the most suitable links designs, diverse alternatives have been considered. And we believe that a set 1 featuring the 500 megabit per second speed rates emerged as the most feasible choice for both NRZ and RZ modes, as it satisfies the criteria for both modes, demonstrating its capabilities to manage the specified bit rates with acceptable transitions time degradations. A set 1 provides a well-rounded solution that caters to current requirements and potential future growth. While if there is a need for a higher bit rate, set 2 becomes a feasible alternative with its 1 gigabit per second bit rates. However, it is only achievable with an NRZ modulations, while on the contrary, set 3 falls short of the meeting because it doesn't fulfill both NRZ and RZ line coding modulations, given its 10 gigabit per second bit rates. Next. Okay, that's all for our presentations. Thank you.